Hello everyone. Today we're going to do truth tables for arguments. We're going to try 6.4 Roman numeral 1 and 2. I have a total of 6 problems that I want to go over. The first are what we might call word problems, and the second are just in symbolic form. But you have to put both in symbolic form to test them in a truth table. So what I always do first with these word problems is just read them through. If national elections deteriorate into TV popularity contest, then smooth-talking morons will get elected. Therefore, if national elections do not deteriorate into popularity contest, then smooth-talking morons will not get elected. So, N for national elections, and if they get elected, then smooth-talking morons will get elected. And that's a premise. We know it's a premise ending because there's a period after the word elected. So you separate that premise from anything else. Therefore, if national elections do not deteriorate into popularity contest, then smooth-talking morons will not get elected. If not N, then not S. Now, since you would ordinarily separate one premise from another with a single slash, but since this is just one premise and a conclusion, as we know because the word therefore precedes the last statement that we know it's a conclusion, then we just go right to the conclusion. So one premise to a conclusion, starting off rather simple. With N, we know there are two possible truth values. So it's two true and false, and so you have two letters and two truth values, so 2 to the second power. Under S and under N, the same as you did N before, true, true, false, false. Under S, true, false, true, false. The reason you alternate is that you get all 4 combinations again. Notice true, 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 false, false, true, false, false. There are no others. I like to number these. It's not a requirement, but to number the columns, but it's easier to refer to them while teaching them. So if N implies S, T implies T is T, T implies F is F, F implies T is T. Look at your truth functions. F implies F is T. When is T implies F false? When the antecedent part, or in this case N, is true, and the consequent part is false. Then and only then, and that's why we only got F on that second row. Okay, not N. Negation we're under N. F, F, T, T. Not S we can take care of. Not true is false, not false is true, not true is false, not false is true. Now I can get column 6 by going from negation under 4 to negation 7. We're not looking at N implies S, but not N implies S. So F implies F is T. F implies T is T. T implies F, F. T implies T is T. So the main operator for this conclusion is column 6 in this case. The main operator for this premise is the only operator, which is column 2. In order to get the values under the double slash, where we keep score essentially, is you go from 2 to 6. So true to true equals true, false to true equals true, true to false equals false. We don't have to go any further. If you find one sentence where you have true in the premise and false in the conclusion, then that argument is invalid. So that's T in the premise and false in the conclusion. T implies F, F, and that's invalid. So, because if the definition of validity is if we assume the premise is true, the conclusion will be true. When is that violated? When the premise on some one row at least, in this case the third row, premise was true under the main operator and the conclusion was false under the main operator. That combination renders it invalid. We'll go next to number 4. So again, get yourself into a kind of system. You read through the problem. If there are dried up riverbeds on Mars, then water once flowed on the Martian surface. There are dried up riverbeds on Mars, therefore water once flowed on the Martian surface. So that's 3 propositions. You're going to need, looks like 2 premises and a conclusion, and they tell you what letters to use. D for dried up riverbeds on Mars, and W for water once flowed on the Martian surface. So that's first premise, D, implies W. Then separate that from the second premise. There are dried up riverbeds on Mars, it says. That's D. Therefore W, water once flowed on the Martian surface. Right, is that valid or invalid? Well, again, you have two truth values, true and false, and the exponent is the number of letters, in this case 2, so 2 to the second power, 4 rows deep. True, true, false, false. True, false, true, false. Whenever I see D, I put what I did the first time. When I see W, I do what I did the first time. This one's simple by even comparison to the last one. I count 5 columns. So, in order to get column 2, the main operator under the first premise, I have to look at 1 and 3. True implies true is true. True implies false is false. False implies true is true. False implies false is true. You don't have to circle it, but I just easier on my eyes if I do so. Now the others are done. They're single letters and there's no operators in them. So you have to go by row and see if you can find, in this case, 2 true premises and a false conclusion. If you find that, then it's invalid. If you don't find that, it's valid by default. So true, true, true. That was close. You had 2 true premises, but that's true. False, false in one of the premises, you can automatically put true because what you're looking for is true in both premises. True in one premise, false in the other. That automatically passes, and true in the consequent and the conclusion. And then true in one premise, false in the other, and false in the conclusion. Here what we were looking, we didn't find what we were looking for to render it invalid. Since they're all true, it's valid. To make it invalid, we would have needed to find true in one premise, true in the second, and false in the conclusion. If you find that with 2 premises and conclusion, the argument's invalid. If you don't find it, then by default it's valid. We might have done this one the other night, but let's do it again anyway, because we didn't have a whiteboard to do it on. Einstein won the Nobel Prize either for explaining the photoelectric effect or for the special theory of relativity. But he did win the Nobel Prize for explaining the photoelectric effect. Therefore, he did not win the Nobel Prize for the special theory of relativity. Therefore indicates the conclusion, of course, and you have 2 statements before that. So again, it looks like 2 premises and a conclusion. The letters to be used are just 2, P and S. P for photoelectric effect, S for special theory of relativity. And this would go like this. First premise, he won it for the one thing or won it for the other. Separate that from, but he did win the Nobel Prize for explaining the photoelectric effect. Separate that from the conclusion. Therefore, he did not win it for the special theory of relativity. Now I know, because I know the rule of inference, that this is a violation of a disjunctive syllogism. And so it should test to be invalid. Those are things that are down the road in the course, but in any case, true, true, false, false, true, false, true, false, true, true, false, false, true, false, true, false. And then what I can do 2 things. I can get the main operator P or S. So it's a P, it's an OR, so the wedge indicates one or the other will be true. Maybe both, but even if just one is true, the whole disjunction is true. So true or true makes true, true or false makes true, false or true makes true, false or false makes false. Okay. And I can get not S. Not T is false, not false is true, not true is false, not false is true. Looks like we've got 6 columns, might as well number them. In order to get to the test of validity, we have to look at 2, 4, and then horseshoe 5. We're not testing S, we're testing not S. So true, true, false. On the first row, we have false here. I don't need to see what the other rows are going to be, but a true premise, another true premise, coupled with a false conclusion makes what? Invalid. We can test the other rows. It doesn't matter whether they're you get 2 true premises. You don't, in fact. But since you found 2 true premises and a false conclusion, the argument is invalid. Okay. Number 10 contains 3 letters, and so we're going to have to go it's a bigger truth table. Okay, so again, using your method of if racial quotas are adopted for promoting employees, then qualified employees will be passed over. Semicolon, not the end of that premise yet. But if racial quotas are not adopted, then prior discrimination will go unaddressed. Either racial quotas will or will not be adopted for promoting employees. Therefore, either qualified employees will be passed over or prior discrimination will go unaddressed. Okay, so you're given 3 letters to work with. It says R, Q, and P. Well, if racial quotas are adopted for promoting employees, that's R. And then it says qualified employees will be passed over. Then it says but is like and, it's a conjunction. So I'm going to need here, since it's still the same sentence that tells you it's just we're working with one premise, if racial quotas are not adopted, prior discrimination will go unaddressed. P for prior, yeah. Okay. Then you have, it says, either racial quotas will or will not be adopted for promoting. So R or not R, new premise. And then you're going to have a conclusion. Therefore, either employees will be passed over, or qualified employees will be passed over, or prior discrimination will go unaddressed. So Q or P. Well, you probably ought to number things just so we can refer to it. 4, 5, 6, 7, 8, 13, 14, and 15 columns. Okay, well, 3 letters, so 2 to the 3rd power this time. Q, you alternate. It's 4 true, 4 false, and under the first letter, then alternate 2 true, 2 false, 2 true, 2 false under the second letter. This is still the first letter, R. Okay, P, new letter, alternate. R again, so 4 and 4. R again. Q, that's the second letter we saw, so 2 and 2. And then P, the last letter we saw, we alternate. Okay, should have go all the way down. So you can take care of the first operator here going left. So true implies true is true. Implies true is true. True implies false is false. True implies false is false. The rest should be true. False implies true. False implies false. True. All true there. Okay, so this is more false. So false implies false is true. Then I have to get not R, because I can't get the operator under column 7 until I get what not R is. So not true, false, not true, false, not true, false, not true, false, and then not false, true, 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 and true. Now it's not R implies P, so it's 5 implies 8. False implies true is true. False implies false is true. False implies true is true. False implies false is true. True implies true is true. True implies false is false. True implies true is true. And true implies false is false. Okay. And now I can get 4, because that will be the 4 will, to get 4 I'm going to use 2 dot 7. Okay, the main operator in the first half of the formula, and then the main operator in the second conjunct. So true and true makes true, true and true makes true, false and true makes false, false and true makes false, true and what is this? 2, 3, 4. That's true and true is true. True and false is false. True and true is true, and true and false is false. Okay. Not R. You're gonna have 4. Not true is false. Not true is false. Not true is false. Not true is false. Not false is true. Okay. And then R or not R. So true, if that's always going to be true, because it's a it's Aristotle's law of the excluded middle. It's only two possibilities. Something is or it isn't. So true, 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 and true. Finally, Q or P, true or false is good enough. So true or false or true is true. False or false is false. True or true is true. False, true or false is true. False, true, and false or false is false. Okay, so what we're looking for here is two true premises and a false conclusion as before. So we're going to look to column 4, the main operator of the premise. Column 10, the main operator of the second premise, and then column 14, the main operator of the conclusion. And again, what you're looking for is two truths and a false. That is to say, two truths in the premise and a false conclusion on some one row. So I can, anytime it's true, and I can just skip to those lines where it's false in the conclusion. That's line 4, and there I find a false in this here. A false there, so that's automatically good. The 5th line, I have a true in the premise and a true here. So true, true, and false on row 5 indicates it's invalid. Okay, that is to say true in this row here, true. True under this premise here, the second premise, and then false in the 5th row there. So it's 1, 2, 3. This row is the one that is invalid. Okay, and I got a little out of line there, but you can go back and stop that and you play the video and see how that works. Okay, so now we're going to take some that are not word problems, 6.42. So 6.42, you're freed from the word problems for a bit. You're just going to test these arguments in a truth table. And so I'm going to do numbers 1, 4, and 7, which are the starred numbers. So you have the first one, K. If K is true, then K is false. That's the premise then underlined, and so that separates the premise and the conclusion, therefore not K. Okay. There's only one letter, despite all that, so true, false are the only possible values. Not true is false, not false is true. False, true. Okay, in order to get 2, I have to look at 1 implies 3. So true implies false is false, false implies true is true. In order to get the values for this argument, I look at 2 implies 5, and I get false implies false is true, true implies true is true. This is a valid argument. Okay, so K implies not K implies K is a valid argument. Let's take a couple more. Take numbers 4 and 7. Well, 4 says there are two premises. It's false that G and M are true. And then it says M is true or G is false. And then it says G is false. So GM, it's still only 2 letters, thankfully, so you only have 4 rows. So it's false that G dot M. You separate that from the second premise, which says M or not G. Okay, only thing they've done the argument vertically, you draw the argument with a truth table horizontally, and then you get a conclusion of not G. Okay? Well, we know that, we'll number these for ease of reference. I can't get the negation under 1 because that's outside the parentheses. I must get what's inside first. So true, true, false, false, true, false, true, false, true, false, true, false, true, true, false, false, and then G again, which is true, true, false, false. Okay. Now I can get G. True dot true is true. True dot false. Both have to be true, otherwise it's false, and so the bar is set high for a conjunction. Now I can get column 1 because I just negate what's under 3, right? Not true is false, not false is true, not false is true, not false is true. And that's going to be the main operator for my first premise, so I'm just going to circle it. G is true, true, so negation G is false, false, not false is true, not false is true. In order to get 6, I have to look at 5, wedge 7. True or false is true, false or false is false. 1 has to be true for it to be true, so you'll see the 3 out of 4 are true. Not true is false, not true is false, not true is... Okay, so false is true. So my main operators are circled here under columns 1, 6, and 9. The question is, do I have a row, or 4 rows, on which there's 2 true premises and a false conclusion? And first row, no, that's not a true premise, so you can skip it. True premise here, false conclusion, skip it. True premise here, true premise, true conclusion. That was close, but still not invalid. True, true, and true. So all the values are true. It's a valid argument. How do I know? Because I was looking for true in the premise, true in the second premise, and false in the conclusion. Did I find it? No. So did not find that on any one row under the main operators, and so that's a valid argument. All right, we'll do one more. Okay, so number 7 has 2 premises and a conclusion as well, and you can see them there on page 369, 6.4, Roman numeral 2, number 7, and that looks like this. Negation W dot not X. Separate that from the second premise, which is negation parentheses X and not W. Separate that from the conclusion, which is X or W. Well, thankfully just 2 letters, and so 4 rows. I filled those in. Not X is false, true, false, true. True dot false is false. True dot true is true. True false dot false is false. False dot true is false. In order to get column 1, I have to get the negation of 3. Okay, so not F is, right, this goes right to that. So not F here is T, not T is F, not F is T, not F is T. Those are the main operators there. In order to get 6, I must get 8 first. So true and first I would get 9. So not W is F, F, T, T. So 7 and 9, true and false is false. False and false is false. True and true is true. False and true is false. In order to get 6, I negate what I found under 8, the dot. So this goes right to that. Negation, false is true, true, false, and true. So now I've got the main operator for the second premise. The conclusion, true or true is true, false or true is true, true or false is true, false or false is false. That's under 12. So what do I have to look at? 1, 6, and 12 in order to get the values under the double slash. 1, 6 implies 12. Alright, so true, true, and true makes true there. False, true, and true makes true there. True, false, and true makes true there. True, true, and false on the very last row. So this argument is invalid because of this row here, number 4. I was looking for 2 true premises, true, true, and I did find it on the 4th row. So this argument is invalid. Okay, so I'll be going over these as soon as possible, so take your time with them and do well. All right, bye-bye.